So in all the videos so far that have covered U-substitution, we've dealt with this idea that maybe we have some integral that exists over in X land that we want to take to U land because we identify that the chain rule has taken place. And so we're trying to figure out how to simplify this integral and make it easier for us to work with. And so in this particular case, if we choose to let u equal sine of x, then du is going to end up equaling cosine of x dx, right? And if we make this substitution, in the last videos, we essentially just got to the point where we're doing the integral of u times du, right? That our du is equal to cosine of x dx, our u is sine of x, and I'm abbreviating a few steps in this whole process. So if you're wondering how I just got that, definitely check out the last videos. That way we can all make sure we're on the same page. But the way that we've been doing this is that once we got here, we're like, okay, I can solve this integral. This is u squared over 2, and since it's going to be a definite integral, there's no plus c. And then we would take the train back over here and say, well, since u is equal to sine of x, right, we would end up with sine squared of x over 2, and then we'd evaluate it from 0 to pi over 2. And so in this case, right, what's sine of pi over 2? Sine of pi over 2 is the y value, pi over 2 on the unit circle, and that's 1. So this is going to equal 1/2 here. And then minus sine of 0, which is just going to be 0, so minus 0. And so we get that our answer is 1/2. Okay, great. So evaluating this particular integral should leave us with 1/2. Great. But you'll notice that while we did a great job of bringing along, right, we turned this into a u, we turned this into things with u, we brought the integral symbol itself, the one thing that we didn't touch in any of the last couple of videos was the bounds. We just said, look, you can get the integral over here, you can solve it, and you can go back because eventually, right, the purpose is to actually solve the integral. We can't technically fully solve it until we evaluate these bounds right here. But it turns out that, you can actually bring the bounds with us if we like, and that's actually a nice shortcut to basically finish the integral over here in U-land. So what do I mean? When these bounds are all, right, x equals and x equals. And so we can use this relationship that exists between u and sine to say that, not only as we use this kind of ship to get over to U-land, right, for the core components, for the integrand, we can use it also for the bounds. And so we could say that since x equals pi over 2 is a bound, right, is our upper bound, and you don't have to write this out every time, just doing it for the sake of the video, is our upper bound, then, using the fact that u equals sine of x, we get that u is equal to sine of pi over 2, which is equal to 1, is our upper bound in U-land. Okay, and so that means that I can put an upper bound over here of u is equal to 1. And similarly, if I were to tackle this lower bound, right, I can still use the fact that since u is equal to sine of x, then u equals sine, if I put in that lower bound, sine of 0, which is just 0, that gets me u equals 0 for our lower bound. And what this allows me to do is now I don't have to make this return journey to X-land to finish this integral. I now have a fully ready to be entirely evaluated for a final answer integral in U-land. And you'll notice that if I now evaluate this thing from 0 to 1, I do still indeed get 1/2 for my answer. And this will always work, right? It's this idea that all we're doing, remember, is changing this integral, sending it to U-land with the intention of solving it. And if you'd like to bring the bounds as well, you can do so, right? We're not doing any magical mystical math. It's just that in this particular step here, we eventually have to plug in pi over 2 into our sine function, and we have to plug in 0 into our sine function anyways. We're just choosing to do that ahead of time and then changing our bounds over here. And yeah, so this works in any particular example. I'm not going to do more than this one example because the idea is very much the same for every single example that you do. So if you like this and if you think it's useful, definitely you can start doing it. It's kind of cool. It allows you to just finish doing the integral and you land. You don't have to go back. But if you like the original way, where you don't have these bounds yet, and so you don't evaluate over here, you just do the integral first and then you go back to xland. You can do that as well. Yeah, so that's going to do it for this video. Hopefully you thought it was interesting, and we'll see you in the next one.